Alright, 7.3, logarithms. That's how you say it, logarithms. Logarithm is a fancy way of expressing a power. So we're talking about exponents. Okay? And when we're used to seeing the base be the big number and the power be the little number and it equals some other number, we're going to change that form around. Okay? And this is on page 1068 in your book, if you would rather screenshot, but you can take a picture of this screen too, but don't write it all down. Either take a picture from the book or take a picture from the screen, and then we'll talk about what's going on here. Ultimately, what's going on, where I want you to focus right now is on this. Okay? B to the y equals x. Those kinds of things we're familiar with seeing. Okay? We're used to seeing exponents. B is the base, y in this case is the power, and it would equal x. What a logarithm does is it takes the base and it makes it the small number. It takes the power and puts it on the other side, and it's now a bigger number, and the answer goes right next to the log. Okay? So the way I like to think about it is it kind of circles and cycles around like that. So this is really b to the y equals x. So in this case, 3 to the y equals 27. So it kind of cycles around backwards. And what we're going to have to do today is get used to going from what's called logarithmic form. So this over here is logarithmic form, and this over here is exponential form. And so we're going to get practice going between logarithmic form and exponential form, and then going back from exponential form to logarithmic form. And then we have a couple situations where we actually have to evaluate, and we'll go through some of that. So again, when you see logarithmic form, you're going to write the little number, which is actually the base, and the y on the other side. So this logarithm equals a power. That's important. Maybe write that down. Let's write that down. A logarithm equals a power. So when we see this logarithm over by itself, we're telling you that that equals a power. This other side here, this is actually the power. Okay? And so once we get used to going in between the forms, it'll get easier. So this first set of examples, we have two problems that are written in exponential form, okay, because there is exponents and they equal something. What we're going to do is put them in logarithmic form. So notice on that the picture that you took, okay, remember a logarithm equals a power. So I just start off over here. I'm going to just start with the log like that, and I'm going to skip what's in there for a second. And it equals the power. So in this problem for A, what is the power?
15 to the 35. 3.
3. Just 3 is the power. So on the other side, that's where 3 goes. And it's written normal sized. Okay? The base in exponential form now gets written as the small number. So which number is the base? 15. So now I write that as the little small number there, and so there's only one number left to put in, right? So this just has to be 3,375. Okay? So that's all we're doing for this. When it says write it in logarithmic form, we're just going to put it in logarithmic form. Okay? Remember, a log equals a power. So the power goes over here, the base now becomes the small number, and the answer goes next to it. Okay? So the way that we read this, we say the log base 15 of 3,375 equals 3. Okay? Now, what I want you to do is try to do B. And let's see how you do and see if you got the hang of it. You guys all had it. That's really good. Okay? So the base becomes a little number, so that the base is 4, so that becomes the middle number. The answer goes next to it, and the power goes on the other side. Raise your hand if that's what you had. And I came around and saw that that's what you had. Okay. So that's just writing from exponential form to logarithmic form. Okay, now we're going to go the other way. Now I'm going to give you it in logarithmic form. and I want you to write it in exponential form. Okay, so now we're going to go the other way. So think about on that picture, you had b to the y equals x. That's how I want it to be. That's what exponential form is. So what I want you to do is write it in that form now. And however you write it, it should come out to be like a true statement. It should be true. So you can check it and say, hey, does this left-hand side equal the right-hand side or not? Let's just do the first one. So this looks pretty good so far, all right? So the base for this first one, what is the base for this first one? 2. So the little number now becomes the big number. What's the power here? 3. So I just write 2 to the third equals 8. Is that true? Is 2 to the third?
Yeah.
That does equal 8. So right away you should be able to check and be like, yeah, that works out. Okay, how many had that one? Okay, do the next one if you haven't already. So this is where I was talking about that cycling. So this becomes 2 to the third equals 8. That sort of counterclockwise movement. So, again, if we use that cycling technique, this is 4 to the negative 4 equals 1 over 256. How many had that? Okay, and like I said, you can check that with your calculator. If that doesn't work out to be true, then you probably had it in the wrong order. Okay, so that's going from logarithmic form to exponential form. Okay, so you just have to be able to go both directions. All right, the last thing that we have to do is evaluate. Sometimes you're going to be given a problem like this, and it just says evaluate log base 3 of 81. So what you're trying to find is a power.
I didn't even realize that's a 3 was such a common.
Yeah, it's a little 3 here. I'll make it bigger. Or a lot bigger. How about that?
So we have to find.
So here's what I want you to do. Okay, and what you have to do is think about this. What's important is this is the same as we're just finding an answer. Okay, there's no equation here. There's no variable here. But what I want you to think, and this is why I'm going to write the word think in capital letters. Okay, what I want you to think is what power do I raise 3 to make it equal 81? So this is another situation where you might play around with your calculator a little bit until you find the right number. 3 to what power equals 81? So try to figure that out. What power is it? 4. 3 to the 4th equals 81. Now here's where it gets tricky. And it's not really tricky, but remember that a log equals a power. So the answer actually is just 4. That's my answer. Okay, this is sort of the work that you're doing in your head. Okay, so this is the work that you're doing in your head, but that's not really the answer. The answer is just the power. Okay, so when we get to the quiz on Friday, you can write all this stuff down if you want, because it helps you to think about what the value should be. But remember, since a logarithm equals a power, the only answer here is 4.
So we don't have to
Do not write 3 to the 4th as your answer, because that is not correct. The only thing that is correct is what the power is. Okay? I realize that using it this way helps you to figure out what the number is, but the final answer should be 4. So if you want to have work like this over here, that's fine. Right? But make sure that your final answer is only 4. Whatever the power is. Okay? Whatever that power equals is what my answer is. Are we clear on that?
Just
Okay.
when you're evaluating the expressions.
Yep, when you're evaluating. When you're evaluating, we're just looking for that power. Okay, let's look at one more example. Okay, I'll make this bigger too. Okay, log base 16 of 4. So again, you can think 16 to what power equals 4? So again, you can think 16 to what power equals 4? So how do I take 16 and get it down to 4? You can divide it by 4, but raising it to a power doesn't allow us to divide.
Multiply it by a fraction.
What do you mean multiply? Well, same thing. That's the same
Did
thing.
you subtract it?
Nope.
Oh, you raise it to like a fraction, or 1/2 would be the answer.
Why do you say 1/2?
I don't know, that's on my calculator.
What does the 1/2 power really mean?
Dividing it.
Dividing it by 2.
Nope. Rational exponents. When I raise a number to a fraction, it really means what?
Dividing.
Nope.
So it's like
We just got done doing this. Nope.
radical.
What?
Radical.
It's a radical.
Yay, is it
So what's the relationship between 16 and 4 in terms of radicals? Square root of 16 equals 4. Well, what is the square root as a rational exponent?
2.
Nope. If I wrote the square root as a power with a fraction, what would it be?
4.
The square root equals the 1/2 power. We already forgot about that. That was the last chapter. Just got done doing that. So if I took the square root of 16, I would get 4, which means 16 to the 1/2 power gives me 4. Okay, so that's why it's 1/2. Because when you take the square root of 16, you get 4. And the 1/2 power means the square root. So again, same thing. You can think this, but this is not the answer. 1/2 is the answer. So I raise it to the 1/2 power. So we can't forget about our rational exponents that we just got done going over in chapter 6, because they're going to come up again. But whenever you're evaluating with a logarithm like that, you're trying to find what the power is equal to. That makes it a true statement. Okay? And sometimes you'll have to use fractional exponents, fractional powers. So that's what you've got today, going between logarithmic notation and exponential notation, or going from exponential notation to logarithmic notation, and then evaluate. Okay?